Now we will see the kinematic chain. What is the exactly kinematic chain? What is the use of the kinematic chain? Kinematic chain, when the kinematic pairs are coupled in such a way that the last link is joined to the first link to transmit definite motion. So the definite may be considered as that completely or successfully constrained motion, means we should get a motion in only one direction. Then it is called as the kinematic chain. So for example, take the kinematic chain as the example of this. Right? The crankshaft on an engine forms the kinematic chain or kinematic pair with the bearing, which are fixed in pair. The connecting rod with the crank, this is the connecting rod and this is the crank, this is the second kinematic pair. The piston and the connecting rod, this is the third kinematic pair, and this piston and the frame, that is the fourth kinematic pair. And the total combination of these links is the kinematic chain. Now, when we join the number of links, it forms the number of pair, number of joints. Out of that, we have to check whether this is kinematic chain or not. So, if each link is assumed to form two pairs with two adjacent links, then the relation between the number of pairs P forming kinematic chain and the number of link L may be expressed in the form of an equation, that is L is equal to 2P minus 4. This is equation number 1. Then another relation between the number of link and the number of joint which constitute a kinematic chain is given by the second equation, that is the J is equal to 3 by 2 L minus 2. This is equation number 2, where the L we can say it as the number of links, P number of kinematic pairs, J number of joints, and specifically the joints are the binary joints. Now we will apply these two equations to the few cases. Now consider the arrangement of the three link, that is the AB link, AB, PC and CA with the pin joint at point A, at point B and at point C as shown in above figure. Now from this you can see the number of links are 3, that is link 1, 2, 3. Number of pairs, that is 3, that is when we join link 1 and link 2 it forms one kinematic pair. Link 2 and link 3, that is the second kinematic pair, and link 3 and link 1, that is the third kinematic pair. In this way the three kinematic pairs will get the number of joints, that J is equal to 3. When we join link 1 and link 2 at point B, that is the one joint, link 2 and link 3 at point C, that is the second joint, and link 3 and link 1 that is point A, that is the third joint. So in this way we will get the data. Now from equation number 1, what it says, the L is equal to 2P minus 4. Now we will put this value of L and P in this equation number 1, we will get. So from this 3 is not equal to 2, that is the left hand side is greater than the right hand side. So similarly we will use the equation number 2 and we will check what we will get out of this. Now the equation 2 what is? J is equal to 3 by 2L minus 2. Now if you put the J is equal to 3 and L is equal to 3, we will get again the left hand side which is not equal to the right hand side, that is LHS is greater than the right hand side. When such situation occurs, that is the left hand side is greater than the right hand side, so we can say such type of chain is called the blocked chain and forms a rigid frame or structure which is used in the bridges and the trusses. Now again we will consider the second example. Here the four links are there, that is AB, BC, CD and DA as shown in figure. Now again if we see that the number of links, number of pairs and the number of joints, we will get the 4. Now we will put all the values in the equation number 1 and again we will check. So if we put in this 4, that link L is equal to 4, 2 into P, that is the 4, so 2 into 4 and minus 4, you will get 4 equal to 4. Here we will get the equation that is left hand side is equal to the right hand side. Now we will use the equation number 2, that is J is equal to 3 by 2 L minus 2, J again 4, L again 4. Now if you rearrange, then you will get 4 equal to, that is the left hand side is equal to the right hand side. Now when you will get the left hand side is equal to right hand side, then we can say that since the arrangement of equation 1 and 2 is satisfied by the links, then we can say it is a kinematic chain or having the 1 degree of freedom. A little consideration will show that if a definite displacement theta is given to link AD, keeping the link AB fixed, then the displacement of remaining 2 links, that is the BC and the CD, are also perfectly definite. Thus, we see that a 4-bar chain, the relative motion is completely constrained. Means this body, that as we move AB to some angle theta, then this CD and BC also it will move to the C dash and this D dash. So hence it may be called as the constrained kinematic chain. And this 4-bar kinematic chain, it is the basis for all the machines. Now we will see another example which is having the 5-bar, that is AB, BC, CD, DA and AE. Now if you see the number of links, you will get 5, number of kinematic pairs you will get 5, and the joint J you will get 5. So again we will check from the equation number 1 and 2. If you put in equation number 1, that is L equal to 2P minus 4, then you will get 5 is equal to 2 into 5 minus 4 is equal to 6. So that is, here the left hand side is less than the right hand side. Now again we will put in equation number 2, that is J is equal to 3 by 2 L minus 2, and if you put, then here again you will get, that is left hand side is less than the right hand side. Since the arrangement of 5 link does not satisfy the equation and left hand side is less than the right hand side, therefore it is not a kinematic chain. Such type of chain is called unconstrained chain. That is, the relative motion is not completely constrained, and this type of chain is of little practical experience or importance, you can say.